Okay, so let's learn about notation for derivatives. Okay, so one thing that makes it a bit hard to kind of get started working with derivatives is that there's quite a few different notations that can be used, which can feel a bit confusing at first. So a function or expression can be denoted as f, so a function can be denoted as f. When we work with graphs, then we often use y. We often use y equals f of x. Okay, so f of x is the expression for function f, and y is commonly used instead of f of x. But sometimes people write y of x instead of y. Okay, so for each of these alternatives ways of writing either a function or its expression, then I've written the corresponding notation here for the derivative function or expression. So basically there's three main alternatives which I think were popularized by three of the most famous mathematicians in history, which were Newton, Leibniz, and Euler. Okay, so Newton basically promoted this prime notation, f prime. Okay, so pretty much where you really just take the same thing and you just write a prime instead here. So instead of f, we write f prime. Instead of f of x, f prime of x. Instead of y, y prime. Instead of y of x, y prime of x. Okay, so I think for the math 3B or 3C courses, I think that really this is the easiest notation to use. Okay. Now, for students, once they start getting into math 4, where you work with chain rule and related rates, things like that, then often this Leibniz notation can be better. However, I guess for math 3, then I guess it's not so useful, but we might come across it, so we should know how it works. So basically, you write d by dx to denote a derivative. So if the function is called f, you could call it df by dx. Or for the expression d by dx, parentheses, f of x, yeah? Or if we're calling it y, then dy by dx, and so on, or this d by dx parentheses in the expression. Okay, so basically this d, it kind of looks like a fraction, but really it's just a notation for a derivative, and it just means that we're forming the derivative where the independent variable, that is the variable on the horizontal axis, where that is x, and where the expression is given by this expression here. Okay. Now, also, the Arrigo book also uses this notation, which I think was popular with Euler as well. I haven't really seen this notation used in other books. I think it's used much less commonly. But really, it's just that you basically just take the same thing you would have here, but you just write a capital D in front of it. So if the function is f, the corresponding derivative is capital D f. And for the expression f of x, the corresponding derivative is d, and then f of x, and so on. Okay, so I hope this isn't too confusing. So most of the time I'm going to use this Newton notation, and most of the time that's what the book uses as well. Okay. However, we should know how to read the Leibniz notation as well. The Euler notation, I think you just make sure you can read the book. But then I'm not going to use this on my tests, and I don't think this will be used on national tests either. Okay, so I hope this made some sense. So thanks for watching. Stay good.